Okay, let's take a look on this example. So the goal is we want to use the BF algorithm and we want to start from this S. So this S will be the source, and we want to from the source node A, and then we want to figure out the shortest path to all the other nodes in this graph. Okay, so not just from A to B or A to C, but we want to figure out the shortest path from the A to all the remaining of the nodes. Okay, so we are gonna start the work in the drawing board, and remember, there are in the second iteration there is a outer loop and there's an inner loop. If we go back, so for the outer loop, that is we are gonna iterate for a total of the v minus 1. So if for the v, that is the number of the vertices, so there are 5 vertices, so we are gonna do the outer loop for a total of 4 rounds. Okay, and then for the inner loop, we are gonna iterate for each of the edge. So for each of the outer loop, we are gonna visit each of the edges, each of the edge. Okay, so we start from the first part. So the first iteration, we just set the d for each of the vertices to be infinity, and then for the source, that is a 0. So to do that, we have a total of 5 nodes, A, B, C, D, E, right? So for the A, that is a 0, and then for the B, C, D, E, they're all infinity. So that is the D. So the D is, for based on the current information, the shortest path we can go from the from the source A to each of the other nodes. So far we only know A is the source, and then for the B, C, D, E, we don't even know how to get there yet. Okay, and then for the notation here on the y on this column, that is for the first iteration I visit AB, the first iteration AC, the first iteration BE. So in the first iteration, that is the first outer loop of the second loop, and then I need to visit each of the edge, right? So that is for the first round of the iteration and visiting the current edge, which is AB. Okay, so let's start from here. So when I'm visiting AB, I have important information, which is based on 0, based on the A, I can go to B, and the cost is a -1, right? So I'm gonna update it -1 here. That is, if I go from the A, and then I know the cost of getting to A is 0. And then if I take the path AB, and then the cost to get to B will be a -1. And of course, for the C, I don't know how to get there. For the D, I don't know how to get there. And the same thing for E. Okay, so that is after we finish visiting the AB, we know we can get to B, and then the cost will be a -1. So let's continue. For the next part, the next one, I'm gonna visit AC. So AC is a 4 here. So so this means we have the cost to get to A is 0, and then if we take the edge A to C, and then we can get to the C with the cost of 4, right? Okay, so and we don't know how to get to D and E yet, and then we move on. The next edge will be the BC. Okay, for the BC, if for the B, the cost is a -1, right? And then for the C, we have already know there is a way to get to C with the cost of 4. And then if we go from B, and then we take the BC, and then the cost in getting to C will be -1, and then plus a 3 here, so it will be a 2. So do we want to relax it? Do we want to apply the relaxation? The answer is yes, because now we do have found a shorter path. So that is from A to B, and then from B to C, right? So that is -1 and 3, and then it will be a 2. So that will be a shorter path. So we have to update that. And then the BE. So from B to E, and then we know B is -1 and the B to E is a 2. So we can get to E with the cost of 1. So we update that. And the next part, BD. So we can, from the B, we can get to D, and then the cost to get to B is a -1, and then BD is a 2. So D can be, I think wait. So I think I have to erase this part. I put, okay, so the last part, BE, is a 1. So this should be a 1, and this is an infinity. Okay, so let's move on. Let's talk about BD. So for the BD, we know the cost to get to B is a -1, and then how about BD? BD is a 2. So that will be a 1 here. And then 0, -1, 2, and 1 again. So far we have discovered at least one way in getting to all the possible edges, and we should continue visiting all the edges. So the next one will be the 1db. So D to B. Okay, so for the D to B, D to B is a 1. So D is a 1. So if we go from D to B, and then we can get to B with the cost of 2, but we can already get to B with -2, so we don't have to change anything here. Okay, and then I should know change. We don't want to relax that, because indeed we can get to B by doing the D to B with the cost of 1, but this will bring up the cost of getting to B from a -1 to a 2, so we don't want to do that. And then how about DC? So if we from the D, and then we take the DC, and then we can get C with the cost of 6, and we don't want to do that because currently there is a way to get to C with only cost as 2, so we don't want to do any change, and I do a no change. And then the last one, 1DE. So DE, ED. Okay, so we can have the E as a 1. And if we go from the E to the D, and then we can bring down the D to a -2. So this -2 is smaller than the current known shortest path to D, which is a 1. So we do want to update that. So -1, 2, and 1. Okay, so that's it. So remember, we haven't finished yet. So if we see the iteration, we have done what we have done is we only visited all the edges once. And remember how many rounds we have to do? We have to do a total of 4 rounds, right? So if you want to continue the next round, you have to do the 2AB, you have to visit the AB again, and 2AC, and 2BC, etc. Okay, so we have only done the first pass on the left side, and then move on. We have to do the same process for a total of 4 rounds, and this will guarantee that we will find the shortest path for all the nodes from A. Okay, so well, I guess for this part, well, for this solution, well, I visited the edges in the way that we can discover the most in the first round. Well, and why do we have to follow the sequence of AB, and then AC, and then BC, and then BE? So why do we have to follow this sequence? The answer is we don't have to do that. So let me just do that from another sequence of the edges. So give me 1 second. Let me erase that. And then I want to do that in the reverse order. So I want to do that with, okay, let me do A, B, C, D, E, and then the first pass is the same thing, and I want to just copy that, and after that I want to do 1ED, and then 1DC, 1DB, and 1BC, be D, 1 be E, and then 1 be C, 1 AC, and eventually 1 AB. Okay, so I take this sequence and I just put all the sequences in the reverse order. Okay, so as I said, if we follow the way on the left side, we are able to discover the most in the first round. And what if we just have everything reversed? And what do we have? So at the very beginning, 1A ED, so ED is a negative 3, right? So E is infinity, and E minus 3, we go to the D, that is still infinity. So what does that mean? This means we don't know how to get to E yet. And then we know there is a path from E to D. And then since we don't know how to get to E, we don't know the cost of the E, and then we can't infer what is the cost of the D. So in this case, I'm sorry, there's no change. So I just want to copy everything down here. And then how about 1DC? We don't know how to get to D, right? So, well, even though there is a path we know from the D to C, and I'm sorry, we can't do any update, so I have to copy this. Don't get frustrated. We will get some progress, okay? And then for 1dB, that's the same thing. Since D is infinity, we can't do anything here. And then 1BD, the same thing. Because we don't know how to get to B, we don't know how to get to D. And don't get frustrated yet, okay? So, okay, eventually we go to 1AC. For 1AC, we know how to get to A, the cost is 0. And then for the C, we can get there by 4, and 4 is much lower than infinity. So now, guess what? We have some progress, right? And then for how about 1AB? And for 1AB, we can do 0, and then we can get to B with a negative 1, and then the 4, infinity, infinity. Okay, so it doesn't matter. This is only one iteration, right? So it doesn't matter if you're doing the left side or the right side. That is only for one iteration. And after we have done a total of 4 iterations, I can guarantee you, you're going to get the same thing. So, well, even though on the right side, we visit the edges in a way that we can't discover too much in the first round. It doesn't matter, because after the first round we have already discovered ABC, right? So the next time, well, if we do next time, if we do the 2BD, so we visit the BD in the second round, and then we will discover the D. And then if we do the 2BE, and then we will discover the node E. So eventually we will still discover all the nodes, and then we are going to revisit and then try to find the shortest path between A to each of the nodes. Okay, so the observation is, let me come back. So observation is, well, depending on the sequence of the edges we are visiting, well, the converge may happen very soon, or it may happen very late. However, as long as we do a total of v minus 1 passes, it's guaranteed that we are going to find the solution. So why? Let me go back to this example again. Okay, well, if you consider there is ever a path between A to another node, what is the longest? Well, if we are talking about the number of the hops, what is the maximum of the number of the hops from A to another node? So that should be 4. Why? Because we have a total of 5 nodes, right? So this means with 4 hops, there should be a way that we can go from A to all the other nodes if there is a path. So for example, to get from the A to C, there is a 1 hop solution, A to C, right? If we want to find a longer path, and then we can go A to B, B to E, E to D, and then D to C, right? So, well, the longest we can go is, well, we want to, there should be 4 passes, and at least we can get to the C if there is ever a pass that we can go from A to C. What does this mean? Well, remember, we have 4 outer rungs, and then inside we have inner rungs. That is for the second iteration, right? So why we want to do the 4 here? Because we are going to do 4 rungs, and this 4 is exactly the v minus 1. So this 4 is the v minus 1, and this will guarantee that after we flood the information of the D for a total of 4 rounds, and then for inside each of the round, and then we are visit each of the edges, and this will guarantee that we are going to spread this message. So let me give you an example. So this one, A to C itself is a 4, right? So if we take the 1/2 solution from A to C, the cost is a 4, right? So if we want to go A, B, E, D, C, and then what is the total cost? And then a -1, 2, and then a -3, and then a 5. So the cost will be a 3. So how can we get there? We have to flood this information around for 4 rounds, and then we will send this information, well, we will update this information all the way from A to B, and then B to E, and E to D, and D to C eventually. So eventually, well, from the A to C, from the A to C, and we will update this information for sure. Okay, so that is the proof of the correctness of this BF algorithm. Okay, so I guess that's it, and I'm gonna stop this video from here, and we are gonna continue this course in the next video.